All right, so use this, and feel free to leave this out if it helps the first couple of times through. About this? You want to see it? Does that help? Or, no, it would approach the horizontal. Oh, it could. Well, I'll use that as an example. It's possible that it could do that. All right, so I'm just going to give you examples of motion, and you're going to draw it. I'll do it for you the first time. So, 1, start from rest. 2, accelerate forward. 3, maintain constant velocity forward. 4, decelerate forward until stop. 5, rest for a bit. 6, accelerate backward. 7, decelerate backward until stop. And I think that's enough. Okay? So, what will this look like in a graph? In other words, connect all of this. I told you it was a little hard. So, you understand, so this is like realistic motion. And your graph should look smooth. By the way, on Monday, we're going to do this in front of a motion detector. And the motion detector will like in real time will graph your motion. And then I'll lay like a graph behind it. And then you will have to like try to match it and run back and forth in front of the motion detector so that you like feel the graph. You are the graph. Okay? So, we're going to start from rest, accelerate. This is pretty typical, like you were jumping in your car, you do this. Accelerate forward. Oh, happy with my speed, maintain for a while. Oh, going too fast, slow down, stop, whew, rest, accelerate backwards. Oh, but then decide to change my mind, decelerate until I stop. So, we can do this on distance, velocity, or acceleration versus time graph. Hello. Probably not going to do acceleration, to be perfectly honest with you, because they're kind of boring. So let's try this in both a distance versus time graph and a velocity versus time graph, okay? All right. So we're going to start from rest. Does it matter where we start on this graph? No, that was not indicated. If I said start from rest at the origin, then we would start right here, okay? What's the line going to look like accelerating forward? Yeah, a curve. So, is a parabola that goes like, or more like, okay, make the sound. You want me to teach you how? Go. Who can whistle? Oh, that's good. So you whistle and hum at the same time. If you don't know how to whistle, that's just that. So, and you have to increase the frequency and hum at the same time. All right. So we're gonna go, right? Was that an adult who just walked by? Yeah. I think so. What are they doing? Physics! Okay. Maintain constant velocity. That's going to be a straight line, so that, I've got a little too curvy here. So straight for a while, okay? Decelerate forward until you stop. So now we're going to get curvy again. Whenever you accelerate, decelerate. Okay, so with your physics pointy finger, is it going to be a positive slope or a negative slope? deceleration forward, positive or negative. So now we're just asking which way will the line point? Like uphill or downhill? Show me. Most of you are going uphill. That's the forward part. Good. So now, so the line goes up. Does it go or? Yeah, right. Right. The slope decreases. That's correct. Like that. It's subtle, but that is the point. It should be smooth because this is realistic motion. Remember that we did, I don't know if you remember this, but there was a graph that I had up a couple days ago, and it was blocked, and it was like, immediately you jump from 10 miles an hour to 20 miles an hour. That doesn't happen in the real world. So this is more real world. It's smooth. Now we're going to stop. So what should that look like? Straight line, slope of, horizontal is correct, slope of 0. Good. So we're going to stop for a bit. Then we're going to throw her in reverse and accelerate backwards. So with your physics pointing finger, is backwards uphill or downhill? Show me. Yes, downhill. So that means the line's got to go that way. And if I'm going to accelerate while heading negative slope B, which way does the line go? Does it increase in slope or decrease in slope? Increase, right. So it gets more steep. And then we're going to decelerate until we stop. So that's a decrease in slope. Okay? Do that on the test for me? Yeah. Now, I wasn't real specific about where and how much time. I would say for 3 seconds, for 4 seconds, so you know how far to stretch it on the graph. But what I'm really more concerned about is, do you understand the shape, the concept? Constant velocities are straight lines. Forward is up. Backward is negative slope or downhill. That's what I'm concerned about. Do you understand that?
Down, but your slope's increasing.
Yeah. So is that or?
Yeah.
That's right. You know what's a little sad is you all understand what I'm doing, don't you? Uh-huh. That's what I'm talking about. Now velocity versus time. So start from rest. What's that going to look like? No velocity. Start from rest. Accelerate forward. What will that look like? Positive, negative. What is it going to look like? Positive. Show me with physics pointing finger which way. Oh, that is correct. Maintain a constant velocity. What's happening there? Yeah, what's the slope if it's constant velocity? 0 slope. But we do have some velocity, right? That's a number. So, yep, it's going to do that for a while. Decelerate forward until we stop. Show me with physics pointing finger. Which way is that going to go? Right, back down until we stop. So how far down do I extend this line? Yep, there's stop. That's stop. So stop. Rest for a bit. What does the line do now? Horizontal stays on 0, right? Accelerate backwards. Now where do I go? Yeah, now here's my question. Is backwards a negative slope or the negative quadrant for velocity? It's the negative quadrant, okay? So accelerate means the numbers get bigger but more negative. And since it's backwards, we need to stay in this negative quadrant, but how do I show deceleration? Up. And these don't need to be curvy. On the velocity graph, remember that a change in velocity, unless it's a non-constant change like Hayden was asking about, the change in velocity we're going to assume is just going to be a bunch of straight lines. Okay. So kind of getting this? All right, yeah. We will practice more of this, just to give you a little preview. And